Good evening. Welcome to day 3 of the MPS Talk Series 2021. This series of talks is organized by JetBrains, obviously because they are the developers of MPS, and itemis because they have been using and building on MPS for 10 years, and we share a lot of the experience and history, and so we organize these kinds of things together. My name is Markus Felter. I'm your host for today and actually for the whole week. And I will, moderate the evening to the degree that's necessary. Something I forgot yesterday, which I'm going to say right now. If you have questions that you want to ask the speaker, please type them into the YouTube chat. And I will scan that chat and then ask the question at the appropriate time. I will try to move as many questions as possible to the end of the talk so we don't disturb the speaker. But if your question is like necessary to understand whatever is currently explained, then I might also jump in and interrupt. We have 2 talks today, like every day. Today is Web Day, so both talks somehow relate to bringing MPS into the cloud and into the browser. The second talk will be by a whole group of JetBrains people. They will discuss the biological knowledge base, which is a project in the space of biology that is also the first major use case for what they call Web MPS. And the talk will cover both, hopefully with an emphasis on Web MPS. And the first talk is by one of my itemis colleagues, Sascha Lisson. If you've used MPS for a while, you certainly know the name. After today, you'll know the person. He has developed lots of the platform stuff that many people use. And currently, for about a year now, maybe, he has spent most of his time developing something called Modelix, which is a way of running MPS in the cloud and also bringing some of the editing features into the browser. All right, I think I've mentioned everything for now. So welcome, Sascha. Go ahead.
Okay, yeah. As Markus mentioned, the goal of Modelix is to build a language workbench or modeling tool for the web, for the cloud, that just runs in your browser and provides all the nice cloud features that you know from tools like Google Docs. You can just share a link to a document, or in this case, a model. And yeah, you open this link and can immediately start to work with this model without having to install anything, without having to find the correct dependencies in the correct version, and you don't have to learn Git. So something that's very easy to use, which is important for the users we typically build DSLs for, who are domain experts, who are not developers, and are overwhelmed by the complexity of an IDE and, of course, of Git and everything. So we need something simple, and that's the goal of Modelix. We tried different approaches in the past. We built several prototypes. The latest one is Modelix, where we try to reuse as much as we can from MPS. So we just run MPS in the cloud and add some extensions to provide a web editor on top of it. So this is how it works. Of course, you need a browser. And then there's MPS running in headless mode on the server side. We have a plugin built for MPS that runs an HTTP server and talks to the browser. And the important difference here is a difference compared to one of our previous approaches is that we try to do as much as we can on the server side. So this client library, the TypeScript code in the browser, that's just about 500 lines. And the only thing it does is capturing user input, sending that to the browser, sending that to the server where all the behavior is implemented. And the server, MPS, then responds with an updated UI. So with having all behavior on the server side, we can implement everything in MPS. We can reuse all the languages that already exist for MPS. We don't have to implement anything new to support existing languages. All of them are generally supported by default. Then the models that we added in the browser are stored on a central model server where multiple clients can connect to. That's important for scalability because then we can run multiple MPS instances on the server side and distribute the load over them. And the model server together with a model client plugin is then responsible for keeping all MPS instances synchronized so that they are all in the same state. And then we can, distribute the HTTP requests across these multiple MPS instances. But the same plugin can also be used in your local MPS IDE. You can also connect your MPS IDE to the model server and also keep the model synchronized. And this gives us the possibility to do real-time collaboration between your MPS IDE and the web editor. This is nice while we still develop this web editor. If there's any feature missing in the web editor, you can just fall back to using your local MPS because it works with the same models. And doing this, we can very early start using this web editor in production. It's not production ready yet, but we are working on that. But this approach makes it possible to use it earlier without having to implement all the features that you usually would need in a language workbench. The third thing that can connect to the model server is a Gradle plugin that we have built. So you can run your CI builds with models that are stored on the model server just by running our Gradle plugin that downloads them to the file system, and then everything works as if they were pulled from a Git repository. The vision is also to add more services that connect to the model server, maybe like a model checker that gives you live feedback while you work on the model. And if these model checks are expensive and long running, then this would be problematic to directly run them inside your IDE. And with this approach that they all work with the same model in real time, we can also run different services that give you live feedback. Running everything in the cloud often means that you use Kubernetes. You package everything as Docker images, and Kubernetes then takes care of creating instances of these Docker images. It does load balancing. It starts new instances in case the load increases to distribute the load across these multiple instances. You can implement health checks, so Kubernetes can detect if there's something wrong, your service is not responding anymore, then just restarts it. We have already running such a Kubernetes cluster at a publicly available cloud provider. So if you want to play around with it, just go here. But let's first do that together. I will not use this public cloud. I will use something that runs on my developer machine, just to be safe for the demo. So now let's have a look. The first thing I want to do is connect my local MPS instance to this model server that is currently empty and create some modules and models on the model server. So I have this new cloud view that comes from Modelix, and here's here a list of servers that I already have added here. That's the one that's running locally. And here's all the data that is stored on this model server. Currently it's empty. So let's create something. UA, and also create a model. Now I can bind this to MPS. So now it's available inside my project view, and I can work with it as with any other model. So I add some languages, then create a base language Java class. This is now synchronized in real time to the model server. You can't really see that. To make this visible, let's open the same class inside the browser-based editor. So the page you see here is an HTML page that is generated from inside of MPS. So these are all the modules that are loaded inside MPS. And yeah, below the horizontal line are all the package read-only ones that are shipped with MPS. And above the line are the ones that are stored on the model server. I can open this module, and I see all the models inside of it. Go to the model and see all the root nodes. If I now open this root node, I see exactly what I see inside of MPS. And that's because this is just an image captured from the MPS editor. So the headless MPS that runs on the that runs inside my cluster on the server side also just creates this editor component and then takes an image and sends that to the browser. But there's an active connection to the server, so whenever I change the model on the model server, then also an updated image is sent to the browser. It's not just an image. I can also click into this image. I can also edit the code here. And it's synchronized to my local MPS, so it works in both directions. I have code completion. I have intentions. These are the same intentions that I see inside of MPS. So I don't have to re-implement them. I can just use everything that's already defined in my language. So let's go back to MPS and see what else I can do with the model there. So here, for example, we have support for branches. So I can create a new branch. I can switch to this branch. And if I now edit my model, and this is not synchronized with the browser editor. That's because the browser is still on the master branch. But I could also, someone else could open local MPS instance, also switch to branch B, and then I have real-time collaboration with him on a separate branch. So real-time collaboration also works with branches. I have a history of all the changes I did. So you can see that I just edited the name, and I can load an earlier version. I can just reset back to the branch, and then it's synchronized to the server again. So now I'm a master, and I have real-time collaboration with the browser editor again. This image editor is nice for existing languages that you want to support by default. But we also have But it's also possible to customize these editors to, for a new language that you build, or languages where you want to customize it for the editor, web editor. And there's a new web aspect that we provide for languages, and there you can, for example, specify your own HTML page. So let's have a look at that example. So here I have my entities language, and I said that for this entities language, I don't want to navigate through modules and models and then to root nodes. Instead, I just list all the modules together with the models that only contain entities. So I only have one, and then I open it, and here I have a page that lists that shows me all root nodes on one page. And how do I specify such a page? So here you can see this is the first page, was available under /entities. So that's the path I specify here. And the second page is available here under /entities/model. I can pass a parameter to specify which model I want to see. And you can see that I specify some transformation. So all these HTML pages are generated using an incremental model-to-model transformation engine that we implemented earlier. It's called Shadow Models. Maybe you heard about that. And this transformation engine allows us not to just generate these static HTML pages, but also to use to also implement editors. So, for example, this the root node that I render here, the entity, that's actually an editor that I implemented using this incremental transformation engine. And this HTML-based editor comes with a new notation language. So if you want to use this, you have to re-implement your editors in this web aspect. We don't use anything from this editor aspect. And this, if you heard about grammar cells, so that's an extension to the MPS editor language that is supposed to provide a more consistent editing behavior for textual DSLs by generating most of the editing actions. And yeah, we also have all the abstractions built into this new notation or editor language. And this makes it easier to implement these editors. It's less effort than implementing an MPS editor. I will, so for this entity language, this notation languages, this editor is very small. I will show a more complex example later, but first let's have a look at these transformations that are specified in this page definition. This is how a transformation with our Shadow Models transformation engine looks like. And you can see here I have the repository as input, and I just generate HTML elements. So an HTML div element, and here I iterate over all the modules that are part of the repository, and I filter out those modules that contain root nodes of type entity. And down here, for example, I have, for this model page, I generate a page that iterates over all root nodes of type entity and renders one of these editors. So that's a predefined definition that's part of Modelix. If you want to embed such an editor that makes use of this notation language, then you just call this transformation. And because everything is using this transformation engine, and that also supports multi-stage transformation. We can, what you see here, we can also render the output of a transformation. So for example, you have a transformation that transforms an entity into a base language class and then shows an editor for that. So let's see how that looks like. Okay, let's also invalidate some caches just to be sure. So in here it shows me the Java class that is generated from this entity. And if I, for example, edit this property here, and then this, the setter name is updated. And sometimes it takes a little bit longer, sometimes it's faster. The idea is to get some live feedback of what the transformation output would look like. And because I use an incremental transformation engine to also generate these HTML pages that are not editable, but I still use an incremental transformation engine, I can make use of that to support updating these pages whenever I change the model. So you get that by default for all the HTML pages that you generate with this language. Now I want to show you the more complex example of this notation language. So I have implemented it for the base language class, for base language. And you can see that I have, for example, these flag cells that you know from grammar cells, these optional cells. I have a read-only model access cell, so the expression is directly visible here. So this is a constructor, and the constructor doesn't have a name. It just shows the name of the class. I have these special cells to say that I don't want any space between these cells. So instead of using this punctuation left and right styles that you know from MPS, there's a cell for that. And here's something interesting. If I go back to this class and show this class using this HTML-based editor, and I, for example, create a switch statement here. And this is rendered as a table. Of course, if I use an HTML-based editor, then I can use all the HTML tags. So that gives us a little bit better integration than the image-based approach. And maybe in the future, we will also use some JavaScript libraries to implement additional notations, like a graphical editor. If you build tools for building software, then it's always useful to also build tools for debugging the software. So from MPS, for example, here in language debug, you have a few useful debug tools, and one of them is this Cell Explorer, where you can debug the editor by exploring which actions are defined, which styles, and we have something similar for when you build these web editors. So there's corresponding Web Cell Explorer. And yeah, here can see all the cells that are generated for this editor. And I also see the HTML that is generated in a second stage of this incremental transformation. One thing that's worth mentioning is that here are these action cells. So these are, so in MPS, whenever you have defined a cell, this cell has a UI representation. So it renders something on the screen, and it has some behavior. So you always have a visualization and a behavior. And here in Modelix, we have cells that don't have a UI, that only define behavior. And that's used for example, for generating these flag cells. So if a flag is set, then it generates this constant text. But if flag is not set, then it just renders. Then it just generates one of these action cells that then have a site transformation attached for setting this flag, and being able to generate cells that are invisible into the cell tree makes it much easier to generate our grammar cells abstractions to the cell tree. One last thing I want to demo is our GitHub integration. So here's a GitHub repository from one of my colleagues. It contains a small MPS project, and I can just use the owner's name and the repository name, and use that in a URL that is available on our cluster. And here you see all the tags and branches, and here I can see all the pull requests. And if I go to one pull request and I have two options, I can clone the Git repository at that commit and load all the models in MPS. So if I choose open version, then I already prepared that, because if I now click on that, it would dynamically start a new MPS instance, and that takes a minute until that's done. I can do it here. So it looks like this. They're starting MPS, and it also shows me the command line output. And when it's loaded, then it looks like this. I see all the content that's part of this Git repository and can also browse through that and kind of review this pull request. I don't have to manually find all the changes. I also have a second view. If I here choose show diff, then this is what I see for this pull request. I start this MPS instance and open the diff dialog and take screenshots of that and send that to the browser. And now I can, without starting MPS, I can see a diff of my models inside of a GitHub pull request, and I don't have to read the XML files. I think that's useful as a review tool. And that was the last thing I wanted to demo. Let's get back to the presentation. I have a few more slides about the model implementation and real-time collaboration. So whenever I show this demo, then people often ask me how does all this model synchronization and real-time collaboration work? And I usually say, yeah, it's complicated. I would need another hour to explain that, and I don't want to make the same excuse today. That's why I included a few slides about that. So the first question that I often get asked is, what happens? So assuming I have here a method, a node, and what happens if user A changes the name of this node and user B deletes that node? And yeah, this question gets asked because in Git you would have a merge conflict and you have to resolve this conflict. But in real-time collaboration, you never see a merge dialog. So there must be some magic happening to resolve this conflict. And for this case, it's actually quite simple. If you think about it, what are the options? I can delete the node and ignore the property change, or I can change the name and ignore the delete. But the last option would be very weird for user B because he would delete the node, then he receives a property change, and what needs to happen is that this deleted node is restored with a new name. So that's very unexpected. So there's only the first option. I delete the node and ignore the property change. So for user A, it will look like this. He changes the name and then the node disappears. So that's okay, I guess. That's what users expect. There can be more complex changes. If I re-implement the whole method body, if two users do that at the same time, and I try to merge that, then this is not so easily possible. But the point is, that's not the problem you have to solve in real-time collaboration. You don't have to solve this merge problem that even Git cannot solve, right? And for this example, if you think about it, this is a bigger change. And if two users work at the same time, and it's synchronized in real time, they don't even have the time to change the whole method body. So as soon as you start typing, you will see the changes of the other user, and then you hopefully stop typing because nothing useful will come out of this. So the point is, in a real-time collaboration system, you will never have these complex changes that are hard to merge. You will only have these simple cases that are easy to solve. And yeah, but the point is, even if somehow you can create such a conflict, maybe because both users paste some code from somewhere, and then you are forced to do something useful with it. But yeah, as I said, this is not the problem we have to solve in real-time collaboration. The system will very likely just produce garbage if you have such a conflict. And that's fine, because this is not the problem. You only have to guarantee that the garbage for all users will be the same. And maybe this is not obvious, but if I go back to this example, both users create a change on the model and apply that to their local copy, and then they exchange their change operation and send it to the other user, and that user then also applies it to its model. So they have two concurrent modifications that they apply to their model, but in a different order. And that's the actual problem that you have to solve in real-time collaboration. You have to guarantee that both users, independent of the order that the operations are applied, will end up with the same state of the model. This property is called convergence. And yeah, if you implement a real-time collaboration algorithm, then you have to prove that your algorithm guarantees convergence. Otherwise, bad things will happen, because when you ever have two replicas of a model that are diverged, then users continue working on it. They create operations and make assumptions about the state of the model. And if the other replica does not is in a different state because it's diverged, and it can only get worse. So it's very important to guarantee convergence, but that's the only thing you have to guarantee. You don't have to, when you resolve these conflicts, guarantee that the result semantically makes sense. You can produce garbage as long as you produce the same garbage on all replicas. So there are two approaches to this problem. One is operational transformation, the other is CRDT, conflict-free replicated data types. And I don't want to answer this question, which one is better. And I don't want to go into the details of these two approaches, because for Modelix, I didn't use any of these. I used this third approach, and this is how it works. So that's very, very similar to Git. Actually, it's exactly how Git works. So you've seen that we have branches, and our master branch, for example, just points to a commit, and this commit points to a snapshot of my model. So it contains a whole state of my model. And the only difference is that my commits also includes the list of operations that I applied on the model to create this commit. This is required to resolve these conflicts and also for improving the performance. So yeah, I don't want to go into the details because I don't have that much time, but this is how it works. You have commits that also includes a list of operations, but everything else is almost like it is in Git. And for example, this is how the data structure would look like. It's an abstraction, simplified. But the point is, this is a hash tree. And yeah, Git also works with hash trees, and we have the same. And Git is very good at guaranteeing convergence. And that's because this hash, this commit ID that you know from Git is just it's just a hash over all the content of this commit. And so whenever you have the state of the model, then you can calculate this hash code. And if this hash code is not the same as the one on the server, then you know you are diverged. You can easily fix that. So assuming you have some error in your merge algorithm that somehow fails to guarantee convergence, you will immediately see that by comparing this hash code. And we use this approach because we also have the requirement to store this history. So as Git stores a history, we also want to keep a history. And if we already have a data structure that's capable of guaranteeing convergence that well, then you just have to think about how do you make Git capable of synchronizing in real time, and make this performant enough. And this is what we did in Modelix. We basically built a real-time version of Git, and all our data ends up in a key value store. This is similar to the object store that you might know from Git. So you serialize all the objects that are part of your data structure. So the serialized objects are the value in the key value store, and the key of an entry is a hash over the value. And that's and our key value store looks similar to the object store in Git, just that we don't store files, but we store individual nodes so that we can commit changes on nodes, and we can do a diff on the model, and it will give us not what file changed, but what nodes have changed, and we can efficiently make a diff on the model and get all the changed nodes. And I think that was the last slide. Yes, and now we would have time for some questions.
Yes, indeed. First of all, Sascha, thank you very much. I liked the talk a lot, and there was also a lot of appreciation shown with various chat messages. I think you can probably read the chat later to get an experience of that.
I will.
All right, so lots of questions. First one, a very general one from Federico. What did we, or you, or everybody learn from the previous attempt, Convecton, when building Modelix? And be kind.
Yeah, sure. I don't want to say Convecton was a waste. That's not the case. No. I try to be kind. We learned a lot during Convecton, and most of what I've built for Modelix originates from Convecton. So without Convecton, I wouldn't be able to build Modelix, and I wouldn't have come up with the approach that I now use for Modelix. So for example, this whole model data structure was developed during Convecton. This idea of building this shadow models transformation engine, we developed the ideas for that while we implemented the editor runtime for Convecton. So we reused a lot of experience from Convecton, but at the end we decide. So the difference to Convecton is that Convecton tried to do everything in the browser. So we implemented everything in TypeScript, and the models, the languages, the editor runtime, everything was running in the browser. And with Modelix, we tried the other extreme by running everything on the server. And yeah, at the end, the result is that we decided to continue with the Modelix approach and stop the Convecton approach.
And another difference is that in Convecton, we tried to not use MPS. You strategically decided to use MPS and rely on MPS as much as possible, at least for the time being. And so that's also a very fundamental difference.
Yeah. So for existing MPS users, Modelix is more useful than Convecton.
Yes.
Because exactly. You can reuse your existing languages.
Yeah. All right. So next question. By the way, we have about 15. So just as a is it possible to try out the UI client with a local MPS without using the model server?
Yes. So these two plugins that I showed at the beginning that are part of MPS, so the UI part and the model part, they are totally independent. You can use the web editor without for the models that are maybe stored in Git, and you just check them out into your local file systems, and you can open MPS and edit them with the web-based editor.
All right. How is the communication between MPS and the browser implemented? Michelle asks. Is this WebSockets?
Yes, this is WebSockets. So between the model server and MPS, we use a REST API, and between the browser and MPS, we use WebSockets.
Okay. In the history view, there was a column for author. Is it planned to get some permission mechanism in the future? Federico asks.
This would be difficult to implement in the model. What I can think of is to implement something in the editor so that you can't open some pages that you don't have permission for.
Yeah.
But inside the data structures, this would be very difficult. I don't have a solution for that.
Yeah, but what we definitely have to do is some kind of login and authentication mechanism so that we know, like, really know who made the changes. So that is certainly on the roadmap.
Yes, I didn't show that because I'm running it on my local machine, and there I don't have this login. But here it was. We have this OAuth proxy that allows you to log in with your Google account. And the nice thing here is that it just adds a header with a username so that you can just use that here in MPS and don't ever have to write a single line to talk to the Google API to allow the login. So there's a Docker image that handles everything.
I mean, we haven't done a lot of Chrome around the actual editor, like nice login dialog and nice menus and stuff. This is all yet to come.
But if you open this URL, then the first thing you will see is login for your Google account.
Right, exactly. All right. How performant is it to ship images over the network, especially for root nodes that are a little bit bigger? Asks Dan.
So our data structure stores individual nodes. What again was the question? Sorry.
How long it takes to ship these images, right? It was in the context of the image editor.
Yeah. So if you initially download the model, then you have to download all the data. But if you have an incremental change, on the model, then you only have to download the delta. And if you, I guess he means the history view. If I switch between versions, then I also don't have to download the whole version. I just download the delta between that version and what I already have downloaded.
I think in this image-based editor, you also ship, at least you did this a while ago, you ship partial images, right? You don't send the whole image again and again if you make changes in the image-based editor. You send delta images and overlay them, correct?
Yes. Let me quickly, if I can find this slide. It is. I guess, here you can see that. So I did a change, and then I receive this incremental editor that is just overlaid over the previous full image. It's like you do backups. You have a full backup, and then you do some incremental backups, and at some point you replace all the images by a new, fresh, full image.
Right.
To get.
So in other words, we haven't experienced performance problems on that front. I guess that's what you're saying.
No, we didn't do any extensive performance testing, but for the examples I tried out so far, the performance is acceptable.
Yeah. Okay. Alessio asks, how are merges between branches handled?
So our data structure is exactly very similar to Git. So if you do a merge, which we haven't yet implemented, then you would have the same problem as you have in Git. I mean, you can use this automatic merger, but it will most probably produce garbage. And if you want to use something that's, if you want to produce something useful, then in the future, we also have to implement this merge dialog that allows you to resolve these conflicts in a non-automatic way.
So in other words, right now, we don't resolve the branches. We don't merge the branches.
I mean, it's possible with this automatic merger.
Okay.
As I said, and if you just edited some model part that does not have a conflict with the branch you want to merge into, then this is fine. You can do that.
I also think once, if and when somebody implements this manual merge, it's still easier to do than in Git because you have these change history, right? You have to change commands. So it's semantically more rich than just merging text files, correct?
Yes, I do. So Git works on text files and lines, and here we have nodes, and that's way easier to merge than XML files.
So in other words, the UI to do a manual merge is missing, But the data
Yes.
structure permits it conveniently.
Yes.
Okay. Antonio asks, is there a way to make available only the editors and not the DSL structure for the end user's usage? I honestly don't quite understand what Antonio means by that. Do you?
Maybe he means, if you don't want users to steal your intellectual property and just allow them to edit models,
right,
but don't have access to the language. Yeah, if you deploy that to a Kubernetes cluster, then you don't see the languages, you just see these editors. And yeah, if you never publish your languages, just put them into your cluster that you manage, then users they don't have access to the language, but they can still edit the models. Yes, this is possible.
In the notation definition, Federico asks, we see different colors. Do they have meaning? Maybe that's a question from the colorblind.
Yeah, because I removed all these, these additional brackets that you have in MPS and all these percent signs and that distinguish the different cell types. So instead I just, show different colors for the different cell types. That's the meaning of it.
Yeah, but it's actually a good point that it's maybe not perfectly accessible for colorblind people. I'm not sure if Federico is colorblind or whether the question just came from somewhere.
I actually have a color deficiency so if it works for me, then it should be fine for others.
What about offline use? Can you edit a model offline and synchronize it later?
You could do that, but then again, you have this merge problem.
Right.
Then you don't have real-time collaboration that saves you from having to do these manual merges, but then you are back to the Git experience where you have to manually merge.
Yeah.
But in theory, that's supported because, we just steal ideas from Git. And so in theory, we can also support all the features that Git has.
Right. Okay. Can you see what other users are working on the same route, like see cursors from others people in a Google Doc?
So I already implemented that the user sessions are stored on the model server. And what's missing is that the pages include that into, that the pages generate any HTML that shows the users. So that's something I'm currently working on, but I didn't have the time to complete that for the demo.
Okay. Václav asks a question that comes from obviously somebody who has thought about this a little bit. What is the user experience of undo when multiple users changes collide?
Very nice question. I actually forgot to include that into my presentation. So this is already implemented, and you don't undo changes from other people. You only undo your own changes. And this is like just applying the inverse of a commit. And then you also can use the automatic merge algorithm that is implemented to then resolve potential conflicts between this undo and changes that other users have done in the meantime on your changes.
So you're saying that maybe your undo doesn't do anything because in the meantime somebody else has removed the node on which you would otherwise do the undo.
Yeah, or he added some content and then, it depends. I mean,
but you have separate undo stacks, is what I'm saying. But the question is, do they make sense if the model has changed in the meantime?
Yes, but that's the same problem that you have to solve anyway in real-time collaboration. You have this automatic conflict resolution, and that's also used for undo.
Yeah. Federico again, are there plans to use the model server with other things rather than instead of MPS?
Yes, of course, and I know somebody who wants to work on that. That's Federico himself. So, Federico, if you have plans, then we have plans, yeah.
No, but I mean, seriously, I think one of the goals of the long-term goals is to have other clients. You mentioned the model checker, right? This could be other clients that operate directly on an API on that model server and are not implemented as language behaviors on top of MPS, right?
But if I interpret his question, at the moment, we don't yet store the meta models on the model server. So other clients that are not MPS can't do any useful with the languages. To support other clients, we have also have to put the meta model onto the server, and that then it's completely independent from MPS, and then you can integrate other tools.
Right. But I mean, just to be clear, this is medium to long term. This is absolutely part of the overall story, but not now.
Yes.
Last question, more or less, from Alex. Did you measure the amount of data transferred between the browser and the client? How fast an internet connection do you need to use this system? We're all in Germany, right? We can make do with crappy German internet, so it can't be that much.
I mean, it can take a bit longer to download the initial version, but the thing is, you don't have to download the whole version. If you only look at one root node of your model, then you only have to download that root node. You don't have to download the whole potentially large model. You can. So we have support for partial loading, and it's also lazily loaded, so I can download the part I'm working on, and if I then navigate somewhere else, and I can lazily load those parts of the model that I now need. So because of that, you don't need a fast internet connection.
Okay. 2 more questions in the remaining 3 minutes. How did you implement image editing in the browser? How do you edit images?
Yeah, it's simple. It's similar to a remote desktop. You capture user input. If you click on the image, you just remember the cursor position. You use the coordinates of the inside this image, send that to MPS, where it simulates this mouse or keyboard event, and then you update. You send a new image to the browser. So it's just like remote desktop, very simple.
Okay. And a question that connects to the meta model discussion we had a moment ago. How do you make sure that the meta models are the same on every one of these MPS instances that work together on these models?
I don't.
Exactly.
Yet.
No, but
that's a problem we still have to solve.
The serious answer is that you have to deploy and install the languages into MPS, right? They are not magically transferred if you check out the model. The languages have to be there right now.
Yeah, somewhere we have to also store the language version inside the models, or maybe we have to make them independent of the languages, and then the language have to check if its meta model matches the one on the server.
Yeah, as a kind of at least safety that you don't edit the models with an unsuitable language, right?
Yes.
Okay, so do we have a public roadmap? Yes, there is a website, modelix.org, right?
Yes.
That has a roadmap. Not terribly detailed. Yeah, kind of, exactly. But something, I think, I'm not sure you said it or anybody else said it. This is open source, right?
Yes.
And I think we want people to perhaps maybe not just use, but also maybe help and document and do things like that.
Yeah, of course, at the end, customers with money decide about the roadmap.
Yeah, or the people who volunteer to do stuff, right? I mean,
of course.
Yeah, there's also a Slack channel in the JetBrains MPS Slack team.
Right.
All right. So, Sascha, thank you very much. I thought this was great. Lots of interesting questions as well. Thank you very much.
Thanks.
I'm applauding for everybody. All right. So this was the first of our 2 talks. We are perfectly in time. The next talk will be, I decided I'll just call it the JetBrains gang because it's 5 people. I can't even read all the names because I don't have them in front of me. They will talk, as I said, about the biological knowledge base and about Web MPS. So right now, people are showing up. Ekaterina is there, Elena, Simon. This is a load test for a StreamYard, by the way. We've never had so many people here. Hi, Daniel. So, well, go ahead. Somebody probably wants to share their screen.
Yeah, I'll start. Thank you. So, hello, everyone. I'm really happy to present our project, Biological Knowledge Base, to the conference today. So, I'd like to start from the introduction of our team and overall agenda of the presentation. My name is Ekaterina Zemtsova. I'm a project manager at Genestack. I'll tell you about the entire project and its objectives. The demo of the product will be given by Elena Zimina, a front-end developer at Genestack. She is the best who knows the application from the user's point of view. Danil Ilovkov and Simon Alperovich are software developers at JetBrains. Previously, they worked in the MPS team, and Danil developed declarative definition language for the MPS and created a code generator for Projectional editor web-based. Simon was in charge on Projectional editor support and development. And now they both are working on our project. And today, Danil will talk about how B2B language is defined in program code. And Simon will present how projectional editing works from a server side. So I suppose the JetBrains needs no introduction in the audience. Let me speak a few words about Genestack. Genestack was founded in 2012 in Cambridge, UK, with a mission to address the biggest challenges in bioinformatics. At the moment, it's also located in St. Petersburg, Russia, and the new office is planned in Boston, United States this year. Our team consists of software developers in bioinformatics and biologists. Our expertise lies in storing and querying biological data, so-called omics data, which processed by pharmaceutical, consumer goods, biotechnology, and agri-science companies such as our customers, Roche, AstraZeneca, Corteva, and Unilever. For better understanding what we are doing, I would like to explain what omics data means. So it is a term that represents biological data from genomics, its variations in individuals' DNA, transcriptomics, how gene expression varies between samples or individual cells in different conditions, and proteomics, which proteins are present in sample and how much, and many other examples. I hope it's more clear now. Because of technological development, the amount of all kinds of biological data, such as these, has been sharply increasing. And here, we've come to the part explaining why the project was initiated. So no doubt that rising amount of biological information gives us more knowledge. But on the other hand, it makes working with information challenging. For example, in the area of drug discovery, one possible question is, does a particular substance, gene expression, or protein signature correlate with a particular disease outcome? Another example from the area of education, how a particular process correlates with another process, even if the processes are from different biological areas, and others. So, and which solutions exists? So it is the search in scientific articles and search in existing databases. Both options have their pros and cons. But considering examples I gave, I would say that the first option inefficient because of the large amount of data that biologists discover constantly. And for the second option, I would say that existing databases contain a limited set of data and don't provide any structure that would link them to macro processes. So, to help biologists with the issues mentioned, the main goal for the project was to create a repository of biological information in a structured form with the ability to query it. Here we connected a Genestack expertise in biology, and JetBrains expertise in DSL. So the product we are creating is called a biological knowledge base. Knowledge base consists of a graph of processes and relationships between them. Each process is described by a number of parameters, such as biological entities, gene, protein, issue, etc., and changes to the entities, up-down regulation, drug treatment, dose, and duration. These parameters also describes the biological context. It can be record for each process, or the common context may be set for some of processes. And relationship between processes may be the following types: causal, correlation, logical implication. So the meaning is, I think that it's clear for the titles. So it is very important to note that structure allows us to connect processes from different biological areas. I mean that microprocesses, it is things happening in cellular level, may connect with the macroprocesses, its phenotypic changes, and also connect with biological areas. Its information is presented across all biological data. So, and I would like to show you a simple example. Here, I specified a context, said that organism is mouse, and describe a processes. So, the exposure to malnutrition in the intrauterine period, it is simple to say before birth, is leading to growth restriction and changing one of the gene expression of the pancreas, which is also leading to abnormal development of pancreatic endocrine cells, and which is leading to diabetes in adulthood. So this simple example showed us that we can link different processes from different areas. And also we can find connection between malnutrition in intrauterine period and diabetes in adulthood. So let's talk about how it can be used in practice. In terms of how to fill the knowledge base, the following ways exists. The first one is literature. Here in the picture, it's PubMed. So an unstructured information from the literature is encoded and stored in knowledge base using a combination of text mining and collaborative editing by scientists. In the area of text mining, there is another very interesting project at JetBrains. It's called Paper Analyzer. It is in progress, and we are planning to integrate with them in the future. So the second option is existing databases, such as Pathway, drug clinical trials, and others. And also a manual entering documents written in structured language. So from the business point of view, knowledge base is planning to use as open platform with crowdsourcing model like Wikipedia. And in this case, the users will be charged only for computation costs. And the other option, to use the knowledge base as a private knowledge basis for commercial customers. So now I'd like to hand over to Elena to give a real demo of the knowledge base. And please switch sharing to Elena's desktop.
Hello, everyone. My name is Elena Zimina. I'm a software developer at Genestack. And today it's my pleasure to make a demo of our application, which we are developing together with JetBrains. Okay, so our app looks like this. So here we see, here we see 3 tabs for searching the documents, for creating and editing them, and tab queries to make queries to our knowledge base. And let's start from the editing. make scale a bit bigger. Okay, the main entity in our application is the document. And here on the left side, we see the document explorer. Document corresponds to the root node in MPS. So here, the document are grouped by their concepts. So we see here biological processes, relations, functions, and documents themselves. And here we can do the basic operations with the documents. So we can create a new document of a particular concept. Let's do it. So in the central part, we see an instance of the projectional editor. Yeah, and here we can edit the document. Yeah, to write something. We can delete it or publish it. What does publish mean? Well, we support the versioning of the documents, and publishing means creating of the revision of the document. So let me show you the example. Here it is. Yeah, so the revision history looks like this. We started just with adding a category. A category means a tag. And then we added more variables and facts. Yeah, and now our document looks like this. And we can create a new draft from any revision. Yeah, and we can continue from any place of the document history. I must know that we are working with a real server running the application on Amazon, and I hope that we will not experience any network problems. But excuse me in advance if they will be. Okay, so let's go back to editing. And now I would like to show you our fascinating collaborative editing. So yeah, we created a document, and the other user can open it too. The working copy state exists for every user in our application. It is not like Git, where everyone has their own working copy, but rather like Google Docs. And collaborative editing works like that the users can see each other's changes simultaneously. Let's add the fact and write something. Yeah, so you see that how it works. Yeah, and this kind of magic is supported by our operational transformation server. But let's go back to the language itself. Of course, we are not the first who came with the idea of describing scientific facts and findings in computable language. In particular, there is a language called BEL, which stands for Biology Expression Language. Now it is a community-driven project, and we think that our language is better. That's why it's called BTB, better than BEL. And so let's write something in our language. Yeah, I must say that this editor has zero common code with MPS. It is a completely separate project with its own code base. But we try to carry over the best practices from MPS. So we have similar mechanisms. And let's see how it actually works, how to write something in B2B language. You see that the document consists of fact sets. A fact set is a set of facts, and every fact represents some biological statement. So let's find some statement. I go to NCBI, National Center for Biotechnology Information, and I took a paper, and I would like to write in B2B a statement from the abstract. So we see there are two proteins, interleukin 10 and interleukin 12, and they are produced by pathogen-activated cells, macrophages, and dendritic cells. I've prepared a picture for you. Oh no, picture is here. Yeah, dendritic cell looks like this, and macrophage like this. And when they are activated, they secrete proteins. they are the cells of the immune system of mammals. So they work like this. And let's write it. Let's go back. So the first fact, we need to declare a variable macrophage. And a variable will represent an instance of macrophage. So let's do it. Macrophage. And we need to define its type. Where do the types come from? They come from ontologies. Ontology is another important concept in our language because it is critical that biological entities which we describe and use have consistent names with some common vocabulary accepted by scientific community. So we need reliable dictionaries. And there are some really good comprehensive public sources for definition of organisms, cells, proteins, genes, chemical compounds. I would like to show you the example. Here we see cell ontology. And our macrophage is here and its relations with the upper classes of the cells. So it's important for us that ontologies contain not only the list of the entities, but also relationships between them. And these relationships represent a large amount of already available knowledge. And we can use this knowledge for computer analysis of the biology data. Okay, and it is important that we have imported some ontologies to our project. I can show you here. We have cell ontology, GBI ontology, NCBI taxonomy, and the others. So we can operate with these vocabularies, and let's define the type of our macrophage. You can see that we have a bunch of autocompletes. Macrophage. So the first fact is that macrophage is activated. Cell macrophage. Where did this statement is activated come from? So let's go here. Here we see the process declaration. Another instance of our language, and we see that this process takes a cell as a parameter. So we can use macrophage as a parameter of this statement. And I go back. Okay, and the second fact is that activated macrophage secretes protein. Cell macrophage and protein. I go to the another ontology, uniprot, and I look for protein. Interleukin 10, yes. But we need to define that this fact is caused by the first fact, activation. So I add the causation arrow. Yes, and that's it. We described what we wanted. Activated cell secretes protein. But I would like to add, I would like to tell you about one nice feature. So now these facts look like function calls, and it is not very convenient for human beings, which will write the facts to our knowledge base. And we have a nice feature, custom editors. So let's go to the declaration of activated process. And here I'll show you this feature. We enable the custom editor. You see that the editor looks like the editor declaration in MPS. It consists of cells. The difference is that it is defined not by language designers, but by the users. So the real users, researchers and scientists can define how the editor will look like. And I declare the second process, this one, secretion by cell. I go here and declare that's true editor cell secrets protein. Which protein? Our protein. That's it. So let's reload our editor and see. Yeah, so we see that now our statements look like they are written in natural human language. And if we add some more fact here, fact of secretion, yeah, secretion. Yeah, so we see that the editor itself has changed. Now it looks like like written in human language. Okay, so yeah, we can publish the document now. Publish. And I would like to show you one more real world example. This one. So we have imported the Reactome database. This is a comprehensive database of the pathways, so biochemical reactions in the organisms. So here we see the example from the Reactome, and this is a metabolic reaction, which takes 3 inputs, ATP, cobalamin, and water, and produces 3 outputs, cobalamin, ADP, and this substance, I'll tell you how it is called, yeah, hydrogen phosphate. So yeah, we see the same in our language. We took 3 inputs, ATP, water, and cobalamin, and they have produced 3 outputs. So the real world reactions look like this in our knowledge base. Okay, and I think I can go to the queries. Yeah, computer analysis is a cherry on the top of the whole stuff. So as we have databases, ontologies, and the knowledge from the papers in one place, in our knowledge base, we can try to find some interesting connections between different processes and facts. And let's imagine that there is a researcher who may wonder, is there a connection between cell activation and protein secretion? So let's write it. Activation, yep, and secretion. Secretion by cell. Excuse me, scale doesn't work very cool, but yeah. And we can run the query. And we see the result. Yeah, here we see the result chain. So we have found that activation of macrophage produced protein secretion. And we can make more complex queries. We can define the concrete parameter of the activated cell. So we can write macrophage here. So I won't do it now, but still. So yes, it works like this. And I think, yeah, I think that's all about the demo. Thank you all for attention. If you have any questions, please write them. And now, Daniil, could you please continue with the depth of the language itself?
Yes, sure. Daniil here. So, yeah, Elena has shown us what this B2B language looks like from the user perspective, and I will briefly show how it is defined by the programmer. So, we've been working on this framework for defining languages for running projectional editors in the web. Framework somewhat similar to MPS in purpose, and it's been mentioned by codename Web MPS. And since the last time we showed it, we have actually tried to migrate it to Kotlin. So let's see how it looks now. Well, knowing Kotlin syntax would be a plus, but that's not that important really. So from a very high level, it looks like this. So structure-wise, concepts such as Kotlin classes or interfaces. The rest of language definition is done via some Kotlin DSLs, rather lightweight at the current moment. Plus just some plain vanilla Kotlin code with a little bonus that the framework allows us to track what parts of the model were read during executing that Kotlin code, so that we know what it depends on. No code generation is employed currently. And another interesting thing is that asynchronous execution is kind of everywhere. It's supported natively by Kotlin coroutines, and it's a mechanism in the Kotlin language that allows to write the code in a sequential manner, in a very usual and conventionally looking way, but and have it run asynchronously, as if there were callbacks passed around, stuff like that. And that's very helpful in the situations when we embed our language or the editor into a client-server application, or when, for instance, resolving a reference requires contacting the server. Because contacting a server is always asynchronous, at least for JavaScript code running in the web. Okay, now in more detail about different aspects of language definition. So yeah, from this moment I will be jumping between the slides and the code. So structure, well, all in all, conceptually it's pretty much the same as an MPS, of course. So we have concepts, and they have properties, child roles, references. Just a couple of notes that can be interesting. So speaking of references, in MPS, we have what MPS calls static and dynamic references. In our framework, they're both kind of equally first-class citizens. They're both like two special cases of a more general thing. Next, so yes, concepts are classes and nodes are objects of those classes, obviously. But despite the fact that it's so simple, we try to separate where we define the concept structure or shape, that is, what properties or references it contains, and the particular implementation for nodes. So we can potentially have multiple backing data structures suitable for different scenarios for the same concepts, but in reality we only have one currently. So let's have a look at some code. I have an idea here. Okay, and speaking of structure, so we have this B2B document concept, kind of a starting concept of our language. And it's just a Kotlin interface. Here we define multiple child roles. So it's a val inside the interface. It's like a field or a getter function, if you like. So here we define the type. It's a special kind of list because it's a multiple child role, and the concepts of children, of child nodes. So over here we have something like a behavior method. I will talk about them later. All right, another concept for the notion of fact. We have here we define a single row child is a special kind of property. Well, the word property may be slightly misleading, but it's a single row child, and the type, the concept for the child node. Here, another concept for fact precondition, which Elena showed. Here we see how references are defined. It's just the word reference and the concept of the target nodes. So if we look at the implementing class, fact precondition import. So this is actually the place where we choose a particular implementation that will be used for nodes. So it pretty much mirrors the shape of the concept that I've just shown you, but adds some lower level and implementation details. So here, for example, we say that the same facts that we saw in the content definition, we initialize it with a particular collection of children. We specify the concept. We specify some internal ID. For the reference over here, we initialize it with some implementation, pass again some internal ID of the underlying property that is used to store the reference contents. Here we have a reference to the actual data structure that is used to actually store data of our nodes. And well, that's pretty much it for structure. What I want to say that we plan to evaluate using code generation at least for structure, because Currently, we have to write some boilerplate code by hand as that import class that you saw. We also have some node factories, so it would be much nicer to have them generated. Okay, editor. Again, conceptually, it's pretty much the same as an MPS. So for a given concept, we define what cells the editor will contain. We switch on and off some part of the editor. We define side transforms, delete transforms, we define completion, and we do it in a way that we start from basic building blocks, like this particular text results in this completion action, or like give me all possible target nodes for this reference, and I want to see them in the completion list. And then we combine them, those building blocks, transform them, and we try to do it in a Kotlin idiomatic way. We also support custom editors, as Elena said, and showed. Those are not defined in your Kotlin definition of the language, but defined by the user in their model. And we only support textual notation for now. We plan to support other kinds of notations in a way conceptually the same as what I'm about to show you right now, but we haven't started that yet. So let's have a look at how editors are defined. So B2B document again. Okay, so we say editor of this concept, and then we just enumerate what it will look like. So it's keyword space, very simple things. Here we want to see the collection of children of this role, and if I navigate this reference, this is actually a reference to the role definition side, the concept definition. So we have some import statements inside a document, B2B document, and here we define the editor for them. The editor itself is very simple, not very interesting. Here we define a simple completion. It says that the user can type the word import and produce the node of the right concept. Here, for instance, we define editors for the whole hierarchy of concepts underneath this abstract value concept. And the completion in this case is slightly more involved. We have extracted it into a function. Here it is. So let's look inside, and it follows this pattern. But first we define individual completion lists like this. In the end, we add them all up, the plus operation. And most of those individual completion lists have the form give me all possible target nodes for this reference. And then with the help of map operation, we transform that completion into completion that will produce the nodes of the right concept. Here, for example, we use, instead of reference completion as the basic building block, we use integer number completion. And then we do a simple thing. We construct a node of some measurable value, and we set the amount property inside of it to be equal to the number from the completion. Okay. Now, variable reference value, for example. Okay, the editor itself is not very interesting again. It's trivial. It's just reference content. So to be more precise, show me the reference target, because we can either show the contents of the reference itself or the target node. And what I want to show is here we define a right transform on it. We say right transform, and we define it in terms of completion again. We say that the user can type a dot, and it would complete. It would result in some model transform action described here. So another thing I wanted to show is when we want to either show or hide some part of the editor. So here we have the editor for ontology link. I don't want to go into detail what it means in B2B, but we want to either show or hide some part of it based on some condition in one of the answers to nodes. And we have extracted this logic into a separate function here, optional specialized link. If we look at it, first we define how this optional part will look. Again, it's very simple. It's some keyword specializers and reference to the link that we specialize, because one link can specialize another one. And here we say that we only want to see this part of the editor if the condition specified in this function is true. The function should show specialized. We say visible if and source node should show specialized. So If you look at this function, okay, it's an extension function on the concept of abstract link, and it's very simple. It just tries to find the ancestor node of this concept and check some condition on it over here. But if we look closer, we can see that there are some extra things like this query keyword, and the return type is query boolean instead of just boolean. So there's something going on here, which brings me to the next thing, which is queries or model queries. They are somewhat parallel to behavior method in MPS, but the main concept, the goal behind them, is to track model dependencies of executing this Kotlin function. So what parts of the model were read during execution, with the aim so that we know when something among those dependencies is changed, we know that the result of the function may no longer be valid, it's out of date, and we have to do something about it. So important to understand that it's necessary to have some kind of such mechanism, because for the editor to work, for example, because the editor has to re-highlight stuff when something changes. So how do we go about it? How do we define these query functions? So it's pretty much just plain Kotlin code with minimal decoration. So in this little snippet of code here, I've highlighted those things which make it a query function. If we remove them, it's a completely ordinary Kotlin function. So what do we see here? We see query keyword, and we see some extra parens on those parts on which we actually depend. So it's either a part of the model, like child here, or the result of another query function, like query method here. And okay, important to understand that those strangely looking double pairs of parens are not some magic syntax. It's actually a perfectly normal Kotlin expression. It's just we define on the object that query method returns, we define the invoke operator, which Kotlin allows us to do. So the second pair of parens is just calling that invoke operator. But of course it would look, yeah, and the question marks, don't look at them. They have nothing to do with this query thing. It's just Kotlin syntax. And of course it would look nicer if we didn't have those extra parens. And of course one might easily forget to add those extra parens. And yeah, and they would risk kind of taking a value of something and without recording the fact that we depend on it. So that would be a bug. But the good thing is that we've done it in a way that it would be a compiler error if we forget to add those parens, so we don't forget. Okay, and since those queries are just Kotlin functions, they can be defined anywhere in your code inside the concept, then it would look really like a behavior method in MPS or anywhere else. So okay, now I want to talk about language aspects that heavily rely on those query functionality. So it's error checking rules and scoping rules. So saying right away, no typing rules for now supported. So we're okay with that in B2B currently. So both of those aspects, the definition for them has the form of some lightweight disk plus query Kotlin code. And again, before I jump to the examples, I want to remind that so anywhere inside the body of any of those scoping rules, we're free to use asynchronous calls the Kotlin way. So in the sense that I talked about in the beginning. And another thing is that all the model changes that would affect the results of the rule are automatically taken care of for us. So the rule will be rerun when something changes. So let's have a look at scoping rules first. So we say scopes and we enumerate scoping rules. So here, for example, we say that the node of the concept fact set provides the nodes of concept fact by this logic. And by the way, we say fact set impl here because we currently don't have code generation for concept, and we kind of maintain this tie between fact set and fact set manually here, which we will fix. Okay, and the logic for the scoping rule is pretty simple, just a collection scope of facts filtered by the condition that it's not the fact from which the request comes. So a fact cannot reference itself. We have a construct for default scope concept with with an obvious semantics. Here's an example of a slightly more involved scoping rule. It's bigger, and the icons on the left over here tell us that we're actually making asynchronous calls inside the body of the rule, because we're resolving references here, and resolving references is always asynchronous in our framework. So let's look at error checking. Conceptually, it's pretty much the same. We say error checking, and we enumerate the rules. So here we say check this concept for duplicates, in this case in terms of name, of nodes in this child row. We say the same for a number of other concepts. We say check process declaration, whether it contains cycles in terms of extends relation, because processes in BTB can extend other processes in the same way like classes extend classes, and they can be cycles, and it's an error. So we check that fact here. So just to remind you, if we remove an extra pair of parens, it would not compile. Okay, the next thing is reference resolving. So one might wonder, I've already discussed scoping rules, so why this again? But in our framework is distinct from scoping rules. So using scopes to resolve reference is just a special case. And in the general case, one can define the resolvers in terms of some arbitrary Kotlin code, or instruct the framework to use the remote editor service or remote machine, what we do in biological knowledge base, to resolve references. And also, this is actually the place, reference resolving specification, is the place where we distinguish between what MPS calls dynamic and static references, because we specify some lower level details here, like what we actually want to be stored as the contents of the reference. For instance, we may want to store the name of the target node, or node ID of the target node, or something else. So yes, I think that's all I wanted to say about the framework for now. And yeah, it's all really likely to change a lot. So, and here I would like to hand it over to Simon. Thank you.
Hello, everyone. My name is Simon, and we will look under the hood and talk a little bit more about technical details of our project. So let's start with recalling the simplified architecture of the MPS. What do we have here? We have the model persisted on the disk in the XML format. Then it is loaded to the memory as an abstract syntax string. And then it is viewed and modified by the editor, which is operated by the user. Well, the idea behind the knowledge base is absolutely the same. We have the model persisted now in the database, in the service, in the cloud, and this time it's in the JSON format. And it is loaded to the browser as an abstract syntax string. And then it is viewed and modified by the editor, which is again operated by the user. Great, looking good. But now, unlike MPS, we may have several users. Sorry, they say I have black screen. Okay, sorry. I'm sorry. Okay, I will probably start again. Okay, let's start again. Now it should be better. I'll hide this. Okay, I'm sorry, it's a bit. All right. I have some technical problems, sorry. Okay, we'll do it like this. So once again, let's start from the scratch. My name is Simon Alperovich, and we will look under the hood and talk a little bit more about technical details of our project. So let's start with recalling the simplified architecture of the MPS. What do we have here? We have the model persisted on disk in the XML format, and then it is loaded to the memory as an abstract syntax tree. And then it is viewed and modified by the editor, which is operated by the user. Well, the idea behind the knowledge base is absolutely the same. We have the model persisted in the database, this time in JSON format. It is loaded to the browser as an abstract syntax tree, and then it is viewed and modified by the editor, which is again operated by the user. Okay, but now, unlike NPS, we may have several users. And each user has her own version of the model in the browser. So we need to somehow synchronize their models. And as you may have heard from my colleagues, we do it with the help of an operational transformation service. The service contains the model. So each client is connected to the operational transformation service. The model is loaded from the service to the clients. And then the service processes the client changes to the model and sends updates back to the clients. And this way, all models stay synchronized on each client. Those changes are sent as comments. And an example of comment would be adding new node, deleting node, or changing the text of the property. And remember, we don't work with the text, but rather with abstract syntax trees. So we have our own operational transformation working with trees. Okay, seems fair, but we now face a small problem. And the problem is that our models could be quite big. Imagine, like on the picture, we want to complete the reference to the element from the NCBI taxonomy ontology. And in order to get the list of ontology elements, we need to have the ontology in our model. And this means we should download the ontology. But the NCBI taxonomy in the form of abstract syntax tree is several gigabytes. And we can't afford to download several gigabytes each time a user opens some document, right? So the question is, what should we do? And the answer is obvious. We add another service. This time it is called editor service. And it contains an up-to-date model, which is all nodes, including those big ontologies. And now, as you can see on the picture, the user downloads just a single root node she wants to edit, not the whole repository. And in BTB, we call it like document, as it was mentioned before. And again, this is just a single root node. And now the procedures such as give me completion menu or resolve the target of the reference are executed remotely on the editor service. Great, so let's now dive a bit deeper and take a look at the whole cycle of the editing process. We will take a look at the following scenario. The user will add a new fact to our document, and then she will invoke the completion for the reference inside that fact. So it will look like this. We will add a new fact and invoke the completion menu. Okay, let's go. So here you can see how everything is connected. We see the browser, which is connected to the operational transformation service, and editor service. And editor service is also connected to the operational transformation service. And at this point, I'd like to add one important note. The operational transformation service, for this service, there is no difference between the browser and editor service. They both communicate with the service with the same operational transformation client. So we will come to this again a bit later. Okay, going back to our scenario, the user pressing enter, then the editor in the browser reacts to the section and adds a new fact to the document. We're adding the fact. Then this change immediately goes to the operational transformation service. And then this fact is added to the model of the editor service, which, as I remind, just the same client of the operational transformation service of the browser. Okay, first part is done. Now the user will press Control Space and invoke the completion. Again, the editor in the browser will react to this action and ask the editor service to provide the completion menu. Now the editor service locates the editor for the fact that we just added. So we locate the editor, and now this editor will get the required list of elements from the model repository. And then the editor service returns back to the user. Okay, we're done with our scenario. Now just a couple more words about the editor service. Currently, it is used for reference resolving and completion. And as I said before, it allows us not to send the whole repository to the client. We also do the optimizations. The first one is when we resolve the reference and send the resolved target to the client, we can send only the reduced version of the node, because most of the time the client wants just the target's name, so we can cut off the target's children. And also we send only several completion items to the client, because most of the time the user doesn't want to see the thousands of elements. So this way we optimize the used memory. And we have the further plans to optimize this process, the editing process, and those things are currently when the user opens the editor for the document, we do as many resolving requests as there are references in the document. While in future, we plan just notifying the editor service about the client opening the editor, and it will send all required information with one request. The second plan is to build indexes for big scopes on the editor service. For example, the ontology I showed you, the NCBI ontology and the other ontologies, they don't change often. So we could calculate and cache the list of those ontologies, of those ontology elements, instead of calculating it each time the user asks for a completion menu. And we're planning to bring more functionality to the server. An example would be error checking. So overall, our vision is to make client as lightweight as possible and execute time and memory consuming operation on the server. Okay, great. Well, some of you may have mentioned a small detail. Let's take a look at the picture again. We have here the editor and the model in the browser. Okay, this is just a single document, but it's still part of the model. And also we have the editor and the model in the editor service. And it's not on the picture, but as I said before, we have a model when we run queries, which happens on the document servers. Also, we have the operational transformation client, both in the browser and in the editor service. And it's absolutely the same. So we have the same code, and it's running both on backend and frontend, correspondingly JVM and JavaScript. And the question is, how do we do it? The answer is with the help of Kotlin multi-platform. So we run it once and write it once and run it both on backend and frontend. And this is very convenient. It allows us not only distribute the same code to the different platforms, but also easily switch to the target platform on the development time. For example, originally we had the editor completely in the browser, and then later we decided to move its part to the editor, to the editor service. So we did it without any pain because of the Kotlin multi-platform. So at this point, I would like to just add a couple of words about Kotlin. Let's go. First word is Kotlin is an amazing language. And the second, everyone should use Kotlin. Okay, a couple of words said. Okay, seriously, it's a great language and it has a lot of great features. such as null safety, data classes, extension methods, already mentioned multi-platforming, interoperability with Java. Daniel's shown you internal DSLs and a lot more. So if you haven't already, you should definitely give it a try. Remember, Kotlin by JetBrains. Okay, let's now go back to the architecture. Here's the final overview. We have the front end where the editor is running. Then we have the back end. There's an operational transformation service, which is responsible for collaboration. Then there's an editor service, which helps the editor on the front end. And then we have the document service, where the documents are stored. And the queries are also running on the document service. And also we use the external APIs to import documents such as ontologies and Reactome. Okay, now just final words about our deployment process. We have the code on the GitHub. It is pulled by TeamCity, which builds the Docker image. So we use the Docker, and then we use the Amazon Web Services. This, like microservice architecture and Amazon Web Services, provide us with the easily achieved scalability. We can increase memory and add new instances without changing the code. And also, we can start and stop the services on demand. For example, we may initiate as many editor services as we want. And for example, in extreme cases, we can even initiate one editor service for one client if it would be needed. The same applies for queries. We can initiate a service when the query is started and stop it when the query is completed. Okay, that is it from my side. Thank you very much for your attention. Just one small announcement. JetBrains is currently hiring the software developers for MPS related projects, including the one we had just shown. And here's a screenshot of the vacancy. It's set here, it is for St. Petersburg and Prague, but we also have offices in Munich, Amsterdam, Moscow, and Novosibirsk. So if you would like to work with us, please do not hesitate to contact us. Great, thank you very much once again. And if you have any questions, please ask them in the chat.
All right, thank you, Simon, and everybody else for the presentation. Very interesting. I like the fact that you combined a concrete project with the underlying technology. That's always nice to see a concrete application. So there are lots of questions, and in contrast to what you might think initially, there are also questions not asked by Federico. But before we start with that, I'd just like to mention, if you want people to use Kotlin in this community, I think you know what you have to do, right? You have to implement Kotlin as a base language in MPS, get rid of the old crappy Java. And I guess once you do that, everybody here will start using Kotlin. All right, so first question by Federico. Is Web MPS going to be open source? And when? And why not?
Okay, thank you, Federico, for the question. I will probably answer this. So the answer is we just still don't know. So it's still under development, and probably like we're definitely going to have some commercial license, but we are not sure about open source yet.
Okay, so the when is not relevant because you don't even know the if. Yeah. When will there be an opportunity to use it? Even if it's not open source, there might be some way of licensing it, right? So is there any idea when you might go live?
All right, so I'll probably talk a little bit more about our roadmap. Fortunately, it's not public, but
that was another question. Is there a public roadmap?
Okay, it's not public, but I will talk about this. So currently, our goal is to release the biology knowledge base. So we are currently releasing it internally, and we are now in the process of like finding out the people for narrow, I would say, adoption for like several people. And then lately it will, like after that, the adoption will be like more wide. And then like the first part, like the early adoption will take like, I think, a year. And in the next year, like it will go public. And after we like prove that our technology is like fine, we will go public with like this platform.
So this sounds like at least 2 to 3 years.
Like in 2 years, I would say, yeah.
Okay. Next question.
I would add, yeah, if you can hear, yeah, I think I would like to add, well, not about particular time, but the thing is that the priority currently is this biology knowledge base project, and it's not like Genestack folks are developing knowledge base and we are doing this framework. So we actually all work on biology knowledge base, and we spend some of our time working on the framework. So currently the priority is there. So it's feeding us the requirements and stuff like that. So yeah.
Okay, so meta comment by the moderator, we are basically out of time, but we have lots of questions left. So if you have to leave now because it's 7 p.m., then we hope to see you again tomorrow. But of course, we're going to continue with the remaining questions, and we hope that some people are going to stay around. By the way, there are also some questions about the biology, but I'll put the language questions first because that's kind of more potentially interesting for the community. So Federico asks, do you have something similar to grammar cells in Web MPS? I think he asked that before you showed how you define the syntax with Kotlin, so that question might not be completely relevant, but I'm asking it anyway.
Well, we don't yet have something similar like grammar cells, but we will probably add it a bit later. At the moment, we will develop more like expression-like languages. So not yet, the short answer.
Okay. Federico,
okay,
are you abandoning?
One thing can be mentioned. Okay, there's some kind of delay. I'm sorry. Yeah, so in the projectional editing framework, that there is not only really projectional editor in the narrow, like structured editor, but there's also this hybrid editor, which may be somewhat similar to grammar cells. I'm not completely sure about that. And in the previous incarnation of this tool, which was based on MPS generators, we generated into both projectional editors and hybrid editors. In this at this our Kotlin DSLs can result only in projectional editing, so hybrid editing is currently not used, but it's present in the framework, and so we can employ it at some moment.
Mm. Is the framework still the thing that Konstantin originally developed?
Yes. Yeah, so okay. It wasn't rewritten, it was just migrated to Kotlin pretty much automatically, but with some amount of effort, of course, but yeah, it's the same.
Okay, the last question from Federico: are you abandoning projectional editing for language definition, or because it is a simpler first step to do it in Kotlin, or because you think that projectional editing is bad for developers, or for other reasons?
Yeah, that's a very good question. I actually have already looked at it in YouTube, so I had some time to prepare. Yeah, I think the correct answer would be that we're evaluating whether it would be enough for Kotlin DSLs to provide the means to specify language definition. So it's not like we want it to be projectional or want it to be textual, but it's just there are advantages in having language defined in the same code, in the same language, like the rest of your application. And it's interesting for us to evaluate if Kotlin DSLs are actually good enough for that. And I have a suspicion that for such not a very complicated task in terms of DSLness as language definition, Kotlin DSLs can be enough, but we'll see. So actually, as I said, it's all likely to change, and maybe languages will be defined in a projectional editor, either as an addition to these Kotlin DSLs, or I don't know.
Okay. Here's a question by somebody probably from Russia who wrote his name in Cyrillic letters, which I cannot pronounce. So I'm not going to give you a name. Is the mainstream MPS going to be neglected because of Web MPS? And I swear I didn't make up the question or make up the person. It's a real question.
Okay, I really hope not, but I don't know. They've separated, so it was kind of gradual. But currently there are two separate projects which share only ideas and expertise, so to say, but not the code.
Well, okay, I would add that we are absolutely have zero plans to neglect MPS. We are continue to support it and develop, and we just like have two separate projects, each one having its own way. But we're not planning to neglect it at all. So don't worry.
Okay. So now
yes, it just so happens that the people who are present, the people who are present right here work on that other one.
Yeah, so, and some of the people have previously worked on MPS. That might be a little bit where the question comes from, looking at you, Simon.
Okay.
So now Dimitri asks, could you share some usage experience feedback from real biology subject matter experts? How they like the tool, I guess.
Unfortunately, we don't have like real biology experts currently, but it is like our nearest plan to find one, and we will share the experience like as soon as possible.
So I hope you have some experts, but they're not currently using the tool.
Yeah, of course, we have experts, yeah, and they will start using our tool very soon.
Yeah. Another question in this kind of same direction from Dimitri as well. Are there any estimates on effort required for writing contents of, for example, of a textbook with the biological knowledge base system? Or would this all be imported?
It depends, of course, of the size of the textbook. But okay, once again, we will probably answer this when we start to fill our knowledge base with the knowledge, with the help of those scientists.
Okay.
Sanjit asks, it's important. Sorry. I'm sorry again. Yeah. Actually, important idea is that I don't think that huge amounts of knowledge are supposed to be entered manually.
Manually, yeah.
Yeah, because this paper analyzer project is supposed to help, and which would automatically extract knowledge from papers. So, yeah, of course, manually entering a huge textbook, I think it wouldn't be a good idea.
Yeah. Yeah, that's kind of a thought that came to my mind while you were showing this. I mean, in some sense, you're building almost like a classical expert system, right? You're manually putting in the correlations and the causations and the processes. And today, in general, in many of these domains, there is kind of a trend towards somehow let machine learning do all this magically. And I'm not sure how realistic it is, but I'm surprised to see that you're trying to build something like that manually, or extracting it from some system in a way that's not probabilistic as machine learning kind of is. Sanjit asks, how is the authentication and authorization service implemented? Will JetBrains provide this, or will it have to be implemented by users?
I think we will provide it. Yeah, so it's not it shouldn't be implemented by users.
Yeah, but you haven't. It's not defined yet, I guess. That's your face tells me you haven't done it yet.
Yes.
Okay, but as far as I understand, this biological knowledge base is going to be kind of a real service, not something that can only be deployed on premises, like they say today, but kind of a real service where the user can log in and do stuff. So,
yeah. Okay, last question from Perdita. I know her name is pronounced differently, but I don't remember how. We met at a conference once. So a nerdy question, but Simon mentioned null safety as a key feature of Kotlin, which Simon loves, whereas on day one, Marcus, said that I wouldn't bother with option types anymore in kernel F. So how does this fit together? Do you want to answer? Should I answer?
Yes, please answer. Like, I don't know what. Who should answer this question? Like,
okay, so let me give it a try. So I like null safety and option types as well, which is why I added it to kernel F. But my users, who are business people, subject matter experts, not programmers, they don't care. And so that is, I mean, the customers often prefer to work with an explicit value for nothing, and then write stuff like, if variable dot has value, then blah, else blub, right? So I guess it's different target audiences.
okay, yeah, I agree. So we as a programmers, we love this feature.
Yeah.
Null safety in
Yes.
Kotlin.
Yes, null safety is only for real programmers. Okay, so I think this is a nice conclusion. Thanks again for the presentation. We're out of time and out of topic. We're going to continue tomorrow. Now, I was so busy here that I forgot to look up what we're going to talk about tomorrow. I forgot, but I'm sure it's interesting. So make sure you join again tomorrow at 5 p.m. Central European time. See you tomorrow. Ciao.